All right, this is Algebra 1B Part 1, Unit 5, Lesson 2, Solution Sets of Quadratic Equations. What we're going to do here is we're going to evaluate whether or not a solution set is valid for a given quadratic equation. Quadratic equations are equations where the highest power is squared. The highest degree or order is squared. And all the other terms have x's with either 2 or 3 or 1 or 0, no x at all. These are called polynomial expressions, but more specifically quadratic. All right, and so evaluating a solution set, determining whether or not it is a real solution of the set of the original equation, involves substituting and simplifying. Substitute means we replace the variable with the value. So we're going to substitute 5 for x in the expression. Everything else stays the same. So 5 squared minus 2 times 5 minus 15. We want to evaluate that to see if that is equal to 0. 5 squared means 5 times 5. 5 times 5 is 25. 2 times 5 is 10. 25 minus 10 is 15. 15 minus 15 is 0, not 10. Don't know why I wrote that 1. And 0 does equal 0, therefore this is a valid solution. Now let's check the other. X squared, so negative 3 squared, minus 2 times negative 3, minus 15 equals 0. Negative 3 squared means negative 3 times negative 3. Negative 3 times negative 3. A negative times a negative is a positive 9. Negative 2 times negative 3 is positive 6. 9 plus 6 is 15. 15 minus 15 is 0, and this checks out. So for the first time in your experience, we have an equation that has more than one valid solution, 5 and negative 3. There are many equations that have multiple solutions. Okay, let me set up the next equation here, the next example I want to do. This is not the only form a quadratic equation can take. So let's go to a new slide and write a new problem. X minus 4 squared equals 8. And this time the solution set looks like this: 4 minus square root 8 and 4 plus square root 8. Okay? So we substitute the whole expression 4 minus root 8 in for x. So x, 4 minus square root 8. Everything else remains the same. Minus 4 squared equals 8. Now this parentheses isn't doing anything, so this is just 4 minus root 8 minus 4 squared equals 8. 4 minus 4 is 0. And we get negative root 8 squared. Negative root 8 squared is like this: negative root 8 times negative root 8. A negative times a negative is a positive. Root 8 times root 8 is root 8 squared. And squaring and square roots are just the opposite of each other. It is just 8. Any square root times itself is itself. And root 8 times root 8 is 8. So 8 equals 8, and that checks out. Let's try the other. X minus 4, so 4 plus root 8 minus 4 squared equals 8. 4 minus 4 is 0. So we have 0, or just plus root 8. Root 8 squared, or root 8 times root 8, is 8. So 8 equals 8. It checks out. So both solutions are valid solutions to the quadratic equation. Okay, and I've got one more example for you for this unit. This unit has 2 sections. So the first section is checking the validity of a solution by substituting. The second set has to do with actually finding the solutions to some quadratic equations. And these are quadratic equations that are of this form. 3 times x minus 2 squared plus 4 equals 31. And the form I'm talking about is where there's only one squared and only one x. Only one x and only one squared. In this case, we can solve the equation by undoing, using the principles of equation solving that we've been using all along. That is, we want to get the x alone. We get rid of things by doing opposites. When we do one thing to one side of the equation, we do the same thing to the other side of the equation, balance. And we work backwards. This is a variable x minus 2 quantity squared times 3 plus 4. Plus 4 was the last thing on the pile, the dog pile, so we're going to undo the plus 4 first. The opposite of plus 4 is minus 4. Minus 4 to both sides, balance. 31 minus 4 is 27. So we have 3 times the quantity x minus 2 squared, and we've gotten rid of the plus 4. Now we're going to get rid of the 3, because 3 is the last one on the dog pile. This is a variable, minus 2 quantity squared times 3. The opposite of times 3 is divide 3. The opposite of times 3 is divide 3. And so we get x minus 2 squared equals 9. Okay, now we're down to the step of undoing a square. To undo a square, if I say x squared equals, or a, let's change variables so it doesn't confuse. If I say a squared equals 25, then what I'm saying is that a equals the square root of 25 because we square root both sides. But you must understand that there's a positive and a negative solution. So for example, negative 5 squared is 25, as is 5 squared is 25. And so when we square root, there is a plus or minus answer here. A is plus or minus 5. So here we're going to square root both sides. Square root both sides. And we get a positive or negative solution. X minus 2 equals plus or minus 3. Plus or minus 3. 2 answers. We can write it plus or minus like that, or we can write it negative 3 or positive 3 like this. And I'm going to write it like this for now because it's going to make more sense in the next step. And now we undo the minus 2 by adding 2 to both sides. But we add 2 to both solutions. Negative 3 or positive 3. So x equals negative 3 plus 2, which is negative 1, or positive 3 plus 2, which is 5. And so we have the solution set, negative 1 or 5. And I will save the time, but now what I would do if I were you on a test is I'd plug these back into the original equation and see if they make the equation true. All right, so that's it.